Carl, tell us about yourself and what we can expect, just briefly, and then we'll get to Julie and then do an overview of what you'll be speaking about today.
So I've been a designer for 48 years, and I've worked in my own company. I've worked with large companies and small companies, and I've done several thousand projects over those years, a lot of overtime over a long period of time. So I'm very experienced with the field, and I'm going to be talking about how design engineering works in real life, what the people are that are doing it, and we've kind of come up with a team concept about this. And we have a design team. That's going to be our offense, and we have a manufacturing team. That's going to be our defense, and then we have special teams, and we're going to talk about all the players and their roles, and then we're going to talk about what they do and what they need and how it works, and then we're going to go into a lot of special things that are in the playbook for people, and we're going to go over how different projects get run and some of the advantages of running different kind of plays. So that's our story for today.
All right, well,
is how to play the game.
Well, let me get the rest of the story from Julie this morning. So glad we could talk to you before everything gets kicked off here and before your talk. Tell us about how this design and manufacturing play together, and how designers need to design with manufacturing. I think that's what we're hitting on today, right?
So we think that designers really need to work with manufacturing and manufacturing engineers, because designers are experts in their own field, but they can't be experts in every field. And so the best way to develop a product is to have expertise from all the different people coming together, whether it's the field applications engineers creating stack-ups for the printed circuit board, or the assemblers advising on how they can get better test coverage. And so we're just showing how to pool our resources to get the most brains into the product for best reliability, best product, best cost.
Very good, very exciting. Thank you so much. I think people are some people are coming in right now. We're about go time. So it's been a long time running. I know you've taken a long time to prepare. So thank you very much for all you do. And we're going to toss it back. Please tune in to our presentation here, Design with Manufacturing. And also simultaneously, we've got Designs Team MCAD collaboration and design analysis using simulations. So we're really excited to get started this morning, so we'll flip it back to you. Thank you so much.
Hi, Kelly Dack here for AltiumLive 2022. We're less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go. The show floor, and you know what we plan on, if all goes well, we have some guitar action going on here. We got some friends that like to play, and that's not going to be a problem for you, is it?
No. Do they like tequila?
Are you serving?
Yes, tequila.
Look at this. I had no idea. I thought it was just beer and soda. But Yeah, and we also have lots of water. Push your water
Oh, yeah.
for hydration.
Yes, you're gonna be right on top of the bar for whoever wants to drink little water.
Lewis, we'll be back.
Yes,
We'll name drop. We'll say we
Please.
talked to Lewis. Thanks so much for
right.
being here and for all you do. Great. This is very good. Always exciting. I tell you what, so we don't take up your valuable time, let's dart out. Let's end this segment for the time being. We're going to go get with Andy and Nolan, and we'll pull the guitars out. And that's traditionally what we do at the end of the day here, is pull the guitars out, do a little singing and campfire type blues, and just have some fun and unwind. So please join us for that if you can. And until then, we'll see you tomorrow for the first day of Altium Live Connect 2022. We'll be meeting with all of the Altium management and the people who are going to guide us through what to expect for the show, and all the speakers. And I'll still be on the sidelines here with the live show we'll be covering all week. So really hope you can join us for the next hour or so, or half hour or so, and that you've enjoyed the day. Really appreciated being your host today. We'll see you tomorrow.
Hi, Kelly Dack here for Altium Live 2022. Hey, we're less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go. Hi, we're back live on the IPC Apex show floor. It's in the afternoon now, and we still have quite a buzz on the floor. I'm Kelly Dack, and with me is Ralph Jacobo from All for PCB, and our idea is to bring you along with onto the show floor and meet people like Ralph, who are excited to tell you about their company and what they offer as far as materials and some processes. So, Ralph, tell us about it.
So for PCBs, we supply a lot of equipment and materials for the PCB manufacturing process. One of our key products is going to be ViaFill, which is the Tatsuda material.
Hi, Kelly Dack, Altium Live 2022. Welcome again. It's going to be an exciting day here. We're down here on the show floor, but at the same time, we'll be getting ready for Julie Ellis and Carl Schatke's speak on designing with manufacturing and pulling people together. And if you tuned in yesterday as we walked the show floor, that was our message also. Is IPC Apex Expo is all about this digital transcendence, but we are all about connecting too. So we're merging the two messages together, getting manufacturing and engineering and design to connect. We hear it now. The show is just starting down here on the show floor, and our show is just starting. So also we've got another stage. On another stage you'll see ECAD, MCAD collaboration, and there's another stage too. I don't have my notes with me, but please check it out. Don't be afraid to click around to the different stages. And we're going to try and come in just about every 15 minutes or on the half hour to give you updates from the show floor here and see how everything's going. So again, really glad to be your show host today, and let's all have fun, explore, and connect together.
Hi, Kelly Dack here for AltiumLive 2022. We're less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go.
The sonite paste, and these are primarily used for many applications for building high density type of boards in general.
Tell us about the types of via fill. Designers need to know that for thermal transfer, there's a type of via fill for thermal transfer that conducts heat through the boards and takes it to the other side. And then there are other fills for different purposes. Tell us about those.
So we have traditionally the non-conductive is basically for via and pad technology. This is to save real estate on your designs, basically taking up less real estate. But you have to then fill these vias with the non-conductive material for a cost-effective use.
So vias or even pads or lands that make contact with component connections or component pins or contacts need solder on the top to make the weld between the two. And if there's a via hole, a hole through the board, where does the solder go? It goes through the board. So the solution is conductive or is via fill.
Via fill, right? The non-conductive via fill kind of creates a very stable structure. So when you have a very flat surface, you want to have a very flat surface when you're loading a component. So your solder, you don't have any tombstoning or any kind of a problematic with SMT assembly. So having a very flat structure is important. So that's where the via fill material is used to fill and create a very flat structure. And that's primarily with the non-conductive, and then the conductive material would be for creating a thermal, basically a thermal heat transfer of keeping the BGAs or the component a little bit cooler. So it works as a heat dissipation for that.
So the material is squeegeed in a liquid form or a paste form, and then processed. What's the next process? Are we capping it with copper and plating it so that we get a really flat coplanar surface?
Yeah, so there's a few applications that require equipment to actually fill, to have a proper fill. You want to be able to fill with this material that is basically it's a very viscous material. So you need equipment to fill it. You want to make sure that it's filled with no air gaps in between, no air bubbles. And then you cure the material. You actually then cure the material so it hardens, and then you have to really wipe it off or clean off the excess of that paste of the material, and then you do a plating after. So then when you do your final finish, it creates a nice flat uniform surface finish.
would you say designers are expected to know what type of material to use when they specify via fill, or will designers hang their hat on a IPC spec that says via fill per? How much do designers need to know? Because there are so many different types of via fill in each class. Tell us about that.
There's primarily, just a few suppliers of this of the non.
Hi, Kelly Dack here for Altium Live 2022 Connect. Hey, we're still down here on the show floor. As I mentioned, we'd be darting in from time to time to give you updates and give you a feel of the show floor at IPC Apex here. And with me, Joe Pult has been kind enough to tell us about some another important PCB design stakeholder function, and that's traceability of the boards. We learned all about manufacturing and soldering and some of the processes yesterday, but what happens to these boards once they've been inspected and they need to move on out to the world? How does traceability work? Joe's going to tell us about this. Thank you very much. Welcome.
Kelly, thanks for that great introduction. My name's Joe Pult. I'm the Vice President of the Automation Group for Identco International. Identco is a manufacturer of consumables, labels, specifically for the electronics industry. High temperature, can go through the chemical processes. We've qualified with all the Kaizen and Zestron, and so we know what labels will work with the right process. And in today's age, traceability is so key and so necessary. Everyone's talking about, with all the automation equipment on the factory floor here, everybody's talking about factory 4.0 and having some sense of traceability. And we start with the labels on our side. We have they're manufactured for all the critical processes that they go through.
Let me pause you for a second, Joe. So are we talking mostly just assembly, or is this any product at any stage?
Both. We manufacture, our electronics group is for PCB, board level assemblies, but we also do custom labels as well.
Okay, take us on a tour. Yeah. This is great. Come along.
So I'll just show you some of the examples of the labels that we have for board level traceability, all different sizes, all different material styles. We also do solder mask to protect components in the electronics process, in the manufacturing process, and we also do automation via a feeder and custom automation to print and apply the labels. And we work with all the pick and place platforms out there in the world: Hanwha, Juki, Pana, Yamaha, all the big brands. We have an interface that will work with those pick and place machines, and we have a feeder that will attach to the pick and place machines that will automatically dispense the label. It uses a pre-printed label. This is a Juki feeder that will work on a Juki machine. We have interfaces that will work with all of them, but it's pre-printed labels that are dispensed. The pick and place nozzle will pick up the label and place it anywhere on the board for traceability, giving birth to that board. And then Identco, we can help you with the traceability function as well. Once that serial number is registered, then we can communicate via whatever ERP, MRP system the customer is using, be it Aegis, Oracle, SAP, to then use that data for traceability.
Well, you mentioned, excuse me, you mentioned printing. What are the different ways? You know, there's laser print, there's laser, and tell us about some of the methods. How does the imagery get onto these labels?
Sure. Right here at the center table, we use our printer that we print on demand, right? Any type of serial data, could be a 2D code, linear barcode, human readable, any type of data that you want to put down, we're able to print that data up.
So let's emphasize to us how important traceability is, especially now with where commodities are going and you know, the world needs to know.
It's huge. It's huge. The traceability issue is huge. Just because, you know, once that board starts, they want to know, the manufacturer wants to know all the parts that went on the board. So if there's any recall issues down the road, what batch, what parts went on, if it was 1 reel, 10 reels, so they can have some control of the process of the manufacturing, right?
Very valuable. Looks like you have a great setup. You sell worldwide?
We sell worldwide. We have manufacturing facilities in Europe, Mexico, and the USA.
Okay, so our design, our mostly designer audience, we have a wide audience who I am sure are familiar with marking systems and things. How can they get in touch with Identco and ask more questions?
Sure. Our website is www.identco.com, and I'll give you our main number.
Okay. Yeah, as designers, we love constraints. We need to know the constraints. Like how large are your labels? Where can we fit them on our boards?
Great question. Great question.
So catalogs or data, online data works really well.
Everything's online, so you can access everything online, and we also do custom parts as well as our standard parts that you see. Most PCBs, the standard size is a 1/4 by 1/4 size label. And not only on the board, but we can also place the label on top of a component if necessary.
Very good.
Sure.
Well, thank you so much for your time.
Kelly, thank you so much.
Yes, with me has been Joe Polt from Identco. And again, another stakeholder function is marking boards and traceability of boards. So we thought you might find this interesting, and we'll go find something, some more interesting stuff here on the show floor. Check in with us and do be checking out the other stages that have our featured speakers on there. So for now, we'll sign out. Kelly Dack for AltiumLive Connect 2022.
Hi, Kelly Dack here for AltiumLive 2022. Hey, we're less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go.
The VFL and primarily they are called out with their IPC approved materials. So there's a limited amount of materials that are certified, and mainly when they're called out, it's either going to be a non-conductive or a conductive fill application that is needed by the designers. The designers will decide that. And based off of that information, I mean, we do have certain specifications depending on the materials that they're using. We want to have very good materials that match CTEs and so on. And those properties will consist with the different variations of the materials that we have available. So there are different variations within those.
Some of our audience are emerging engineers, new to the industry, and we tend to use a lot of acronyms in this industry. So when you mention CTE, coefficient of thermal expansion, which means some of the materials don't expand at the same rate as other materials. And it's very important, I think, Ralph will attest that it's so important to find a similar material coefficient of thermal expansion so that you don't get thermal mismatch,
Correct.
which causes what?
Which could cause expansion, which will cause cracks within the plating itself or the barrel of the hole itself. So you want to minimize as much z-axis movement to keep the structural very, very, let's say, consistent throughout the barrel of the plating of the via itself. So that's what drives the connection from top to bottom. So any crack, any deviation will cause a crack in there, which can cause basically opens or misconnection between the top to the bottom.
Very, very good. Very bad issue. What else have you got here? You've got a lot on display. What can you tell us about?
So as I mentioned, I mean, all 4PCB has a lot of processing equipment from A to Z for manufacturing of PCBs. We have lamination consumables here, which basically are materials that are used for the lamination process. So as you take a multi-layer and you basically do your lamination process, there's materials here that are used as lamination aids. So you basically put those in between the materials to get a very conform, uniform lamination press, so you preventing delamination and so on. So within the process. So
any of our designers who have discussed laminates with the suppliers or fabrication suppliers know that we refer to them often as pre-preg, but they come in all different sorts and flavors. And you've got a few down here. That one caught my eye, called a high temp cushion. Tell us about can we see that? Can you pull that out? This is the good stuff here. So what's a high temp cushion and how can that relate to, does that fit within the stack up?
Yes, so this fits within the stack up. So generally FR4 material, which is a base laminate material for PCBs, have a certain lamination temperature that is required to cure the pre-preg and do the lamination process. With some of the new materials, PFTs and so on, there's some hybrid materials that require a higher lamination temperature. And those higher lamination temperatures, you require basically some kind of an interface there so you can get a proper lamination without damaging your product and so on. So withstanding the product temperature during that lamination cycle is important. So some of these materials, we have different variations for flex, for basically.
Well, this is so thick and it's almost a fabric-like feel to it. Does it get impregnated with resins and in the heat and stack-up process?
In some cases, if you have, you can have some resin that goes on there. So we actually have other materials as well that are kind of, we have some release films that would go on the surface of that, so protect it from having any resin flow on there. So again, ideally, this would be kind of a high temperature release film as well that can go, basically in the stack up of the material. So if the combination of both will provide a good, excellent seal against it, protection of the temperature, and then this will protect against any resin flowing onto the surface of that.
Is this material considered for more exotic applications? This is not your basic FR4 stack-up. So is it common in aerospace products and class 3 type products out there?
Yeah, so class 3 products, a lot of, basically newer technologies that are requiring these hybrid laminates, high-speed laminate materials that may require higher temperatures than your normal FR4 materials, yes.
Like I say, I'll say it and I'll say it again, that I just love coming to these shows because this is something new. I have never experienced this material yet. I don't plan on designing any space flight boards in the near future, but that's okay. I do okay. But now I know who to call, and I'm in touch and we've connected, and I'm so appreciative for that. Ralph, with me has been Ralph Jacobo with All for One PCB. Give them a call, look them up online, and ask questions. We really appreciate it. So we're going to move on, and we're gonna keep walking the show floor.
Sounds good. Have a great show.
Thanks for having us. Best to you. Let's go this way. Let's see what we can do. What kind of trouble we can get into now. Another thing with these shows, a lot of the suppliers, the vendors, you know, they have gimmies, they have candy jars everywhere. I'm trying to stay away from those, but they also have, you know, squishy balls and yo-yos and pens and scales or rulers that are quite handy. In fact, let's go check out one right here. Whoop. How about a deck of cards? You know, everybody needs a deck of cards. I'll take them, thanks. Yeah, we love the show floors. We love the gimmies. It's good to bring things home to the family. But since we've taken, let's go back and talk, see if we can talk to some of the notables here. We had one earlier. Let's see if he's still available. Come on. Ooh. We don't usually do it like this, but we made contact and we both said, oh yeah, maybe we'll see. Hi, Kelly Dack, back for AltiumLive Connect 2022. We're back down here on the show floor, and we've been walking around trying to find something interesting for you, and we accomplished that mission. With me is Juan Luis Terren from Smart Soul, and you manufacture machinery for all kinds of, it looks like, inspection and rework. Tell us about Smart Soul and what you're doing. I love the robotics here.
Yeah, thank you very much. Well, basically we're a representative company for all these brands mainly in Mexico. We just started operations in the US last year and Central America. And this is our third time in Apex. Unfortunately, last year we don't have the show because of the COVID situation. But this 2022, we are back here in order to show all the products that we represent and distribute here in the US, Mexico, and Central America, basically.
Well, welcome back. We're glad to have you. Let's maybe we can walk the line here, and you can show us what the equipment does, and see what show us what designers might be interested in as far as how boards are processed. We're trying to connect our designer audience with the rest of the stakeholders in the industry.
Yeah, basically we try to provide the whole solution for the electronics assembly for our customers, and unfortunately there is no enough space to have all the machinery we basically manage. But here you can see some examples of the, let's say, most popular products we basically sell. Here you can see some robots. This is a soldering robot, basically uses to do soldering for PCBs. And we are integrating the solution with a collaborative robot for do the handling, the handling of the PCB. Also, this is just a simple, let's say, application to show the capacity for the robot. It is integrated with a vision system, so the idea is to basically touch the color circle, and the robot identify which color it is and pick the part according to the color.
Can we do it?
I think so. I don't know if it's still working. Yeah.
We just started the show here, so things may not be dialed in yet, but let's try.
Yeah, let me see if it's working. I think it's going.
This is the robot. The robot is on the spot.
Yeah, exactly. We're just opening the show, so
yeah, understood.
we just
our audience will understand.
Yeah, the robot is moving right now. Let me see if I can put more speed on it. So basically, it's gonna touch the screen to pick a color. It's gonna identify the color on the screen and pick up the part. This is just to show one of the features the robot has, which is a vision system, which is integrated in order to basically do some actions according what the robot sees. Okay. See, in this case, it detects the green color. I'm gonna take this out from here because he's gonna look for the part on the tray. Right now,
he's really thinking about it.
Yeah, yeah. Probably it's too early for the robot, you know.
Yes, Sometimes they haven't had their coffee yet. We know how
Yeah.
robots are.
Probably we need to get somebody to get fine tuning here, but the idea is to do that thing with the color. Okay,
Oh, there he goes.
he was missing the yellow one.
He
He
seems to like
just pick it
yellow.
up. Yeah. So this is the general idea with this robot. We also have a screwing robot. We have different kind of solutions for the machinery here. And I don't.
How about around the corner? What are those?
Oh, let's take a look on that.
Yeah, and really appreciate you taking us on a little tour here. And it's so early, like we mentioned, the show just started, so things need to dial in. But you've already you're collecting a pretty good crowd here around your equipment.
Yeah.
Looks like some cleaning equipment here.
Yeah, this is a washer machine. It's part of some kind of processes for certain kind of boards. Idea is to deflux, is what it calls, deflux the PCBs, so the operation of the board in the field could be reliable. So this is one of the solutions we also are presenting on the show right now, and it's up and running now.
Right? This is awesome. Yeah, so cleanliness is a huge issue for circuit boards. Any kind of pollution on the final assembly can lead to what?
Yeah, basically there are products that are critical for certain kind of contamination, like medical product or military product or automotive product now. So idea is to make sure the product by itself or the circuit by itself is going to be completely reliable on the field. And it's going to be no issues with it, because sometimes our security depends on this small stuff, all right?
Absolutely. Can we move on?
Yeah. This another machine is a laser marking system.
We want to see laser marking. We just talked to a manufacturer of label and systems that track things. So maybe you can get a shot in there, Michael, of the laser.
Maybe if you take a look inside, you could see the laser. Basically, we use this machine or the people which are assembling the circuits on the field, uses this machine in order to basically serialize each circuit on the
Each board on the assembly array, or is this bare board, or this is bare board.
Just a test board. Yeah, so we can show the capacity of the machine, of the laser.
How about? Can I ask you a question about this laser technology? How easy is it to laser mark on solder mask versus some designers will put a patch of epoxy, the same material that's used for the legend marking.
Yeah.
What performs the best with a laser? I know it can't be reflective too much.
Correct. It's a good question. Basically, depending on the material, is the kind of laser technology we select. For instance, if we are going to be soldering, if we are going to be marking solder mask, we select CO2 laser technology. Is the best and the cheapest one to do it, all right? If we are going to mark, for instance, metal, like steel or aluminum, we select another kind of laser, which is called fiber laser. So depending on the material is the laser technology it should be selected in order to get the better results, all right?
Very good. And is there a next step in the process? Over here we've got the ER7000. This is great.
This is the paneling machine. It's a milling, the paneling machine technology. Basically, we use this.
This is milling. I see that now. Yes.
We use this kind of machines to separate or singulate the circuits from the main board.
Outstanding.
Yeah. It's a kind of a simple process, but also it should be very precise and very reliable, you know?
A lot of our designers are very familiar with how to create a printed circuit board panel or array. Typically, we send our data out as a one-to-one design to the board fabricator, and we may be prototyping at that point. But once the product goes off to production or volume, they need to utilize the panel, and they will panelize into an array form like this, or a panel. Manufacturing panel, and then they'll cut these panels out into manufacturing or assembly arrays. And yeah, what we're explaining here is what's the configuration? How do we do we determine that slots? Does this do any drilling at the same time if we need mouse bites, what we call mouse bites or anything?
Correct. There is different ways to singulate a PCB into several pieces. This one is, or this panel in a specific for this kind of technology is a mouse bite, let's say, panel construction. But depending on how the designers basically design the panel, we should select this technology or a different technology. Right.
Yeah, so where I was going with that, it's interesting because some designers, we never have a need to panelize. That can be left to, if your board's going on to production or volume production, the manufacturing folks, your EMS provider, whoever's building your assemblies, will take your one-up data and they'll go ahead and panelize it to best fit their manufacturing parameters with the manufacturers they're teamed up with. So, yeah. But the end product is they're going to be using a machine like this to route out the slots so the board can be, some call it X size, that's a 25-cent word, D panel.
Correct.
Yeah.
Well, yeah, and this probably is one of the methods, let's say, that causes less stress in the PCB. I mean, physically speaking. So it's one of the most adopted methods in the manufacturing areas. But you can do it with this. You can do it with press singulation, or even you can do it with laser. Not with this machine, but with a similar machine. You can also depanelize with laser. The only situation with the laser is still very expensive technologies for these days. Probably in the future would be cheaper, and we can do it with laser, which is more clean, effective, and
it can be more accurate. It's widely used, I know, in prototyping flexible circuitry, right? It's widely used in flexible for the laminate materials, FR4, the glass epoxies. Maybe not so much unless it's thin.
Exactly. That depends on the thickness of the material to be cut. That is why it's now becoming more popular for flexible circuits. I mean, the laser. As soon as the material is starting to get thicker, you need more power on the laser, so it becomes more expensive. So probably in the future we can see this technology to lower the price, so we can have it for let's say normal environment of manufacturing.
Very good. Well, Juan Luis, I really appreciate your time sharing with us and our audience. Yeah, best to you at the show here. It looks like you're already successful and you've got some great equipment to show.
Yeah.
With me has been Juan Luis for Smart Soul, and I'm Kelly Dack for AltiumLive 2022. We'll be back at you throughout the day. Stay tuned and make sure and stay connected.
Thank you very much.
Hi, Kelly Dack here for AltiumLive 2022. We're less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go. Each other in about 10 minutes, so let's give this a try, okay? Woo-hoo. Knock, knock. This is the awkward pause because I don't know if they're with customers or not, and we certainly don't want to interrupt them if they're with customers. Let's try something else. Let's go back to the. Have we hit up the Tayo guys yet? Let's see if we can. We're waiting for somebody to be available to talk tech with us, so let's try that. Woo. I'm so tempted to just go in, and these guys look like they needed love, so I was tempted to just go say, hey, do you want to talk circuit boards? But we never do that live. We don't want to catch anybody off guard. Let's try Tayo. You know, sometimes they learn we're coming and they flee. I get the feeling. Let's see what happens. Wow. This is some really cool equipment. They've got equipment here. Tayo is a really unique company from the standpoint of adopting and adapting to your needs, whatever your needs are. They have a bunch of chemists there and R&D people. Let me go see if I can wrestle one up. Come on. Hi. Do you have anybody that can talk to us yet? Oh, Don. He vacated. Hi, Don. Okay. Well, we've got viewers, and you wouldn't mind talking to us just in general about Tayo, an overview, like where are you located?
Tayo America's in Carson City, Nevada.
Right up the street from where or down the street from where I used to live. Fascinating facility, and I got to mention that, you know, this is why we want to come over. We really want to talk tech with you guys, and because you formulate materials for just about any application. And I can share a quick story that we had an application to create some solder mask, but it had to be a solder mask with a grit in it. Who's ever used solder mask with a grit in it, and how would you apply it? These guys solved it for us and solved our customers' issues, so or the challenge. So we really want to connect base, but we don't want to put you on any spots. And who are we meeting up with?
Jesse Session, who is our R&D manager.
Okay.
He's also involved in operations day to day.
Okay. Well, we'll move along, and until we can meet up with Jesse, we'll come back.
Perfect.
Okay. You know, sometimes it happens that way. We're live. So I think what we'll do is let's sign off for the time being, and we'll come back in a half hour or so. Please join us again. I'm Kelly Dack for AltiumLive Connect 2022.
Kelly Dack here for Altium Live 2022. You were less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go. Hi, Kelly Dack here, live at the IPC Apex Expo. Hey, look who I ran into, Mr. Charlie Capers, a good friend from, how long have we known each other? Forever.
Way back.
Yeah, since boards,
20 plus years.
boards were made of phenolic or something like that. So, met Charlie on the show floor. Charlie's from Zentech, EMS provider. And I'm sure you're coming down here to do a little shopping and sniffing things out here. You know, it's first day. We're walking around. We caught you walking around, so we thought we'd walk. And you know, when we walk by machines like this, what does it do? Let's pause here for a second. What does it do? We haven't been in touch with the manufacturer here, but we're on the show aisle, and tell us what you think about some of this stuff. What are some important assembly things to look for an EMS provider, and how it processes and handles the boards that are designed? Tell us all about it.
Well, you know, the things that we're looking for nowadays are more not necessarily pick and place, because if you're in the EMS business, you have plenty of those. But we look for other items such as testing and inspection and things of that, solder paste inspection, things like that. So those are the big things that we like to look at.
Right, because you need to ship quality. The boards are presumed to be quality components when they get to you. Correct. And you combine them together with the other quality components, and you're using solder. We talked to a solder supplier here. Let's keep moving. Yeah. We talked to a solder supplier a while back, and he described some of the issues, outgassing and bubbling and all things that can happen. And they also, then we talked right away to optical inspection, X-ray supplier. So very interesting. It's a critical process, right? What happens when a board gets shipped, or what happens when there is a defect? How do you determine how you're going to resolve that defect? Are you going to, is it correct your line, correct your process, correct your materials?
If it's a systemic defect that keeps on happening over and over, then you've got a processing issue, and you've got to analyze that and drill down and figure out what is causing this problem. Is it a design issue? Is it a fab issue? Does the designer, you know, did he create the part correctly? You know, there's all kinds of things. But for us, we have to kind of drill down and figure out what it is and determine if we need a design change or if we just need to change our process up a little bit.
How often can problems be fixed by design? How often is it the designer did the right thing, designed the best they knew, and when there's a problem, they give you the response that, well, the other guys had no problem with it. What's your response to that?
We've heard that many times. If it really is a design issue, it really is a design issue. If they worked around it, that's great. But, you know, our job is to identify the issues and possibly, hopefully, correct it for future builds, right?
Yeah, and you have to be savvy about how to communicate. You never, I learned in EMS, working in EMS, I still am, that you never want to call the customer's baby ugly, right? No. But there is a lot of issues. In fact, this is one of the purposes for AltiumLive Connect, is to connect our design audience with manufacturers so that they can start this communication, so that no ugly babies get created.
You know as well as I do that us old school designers, we know how to design circuit boards. The guys that are doing it these days, they're engineers that have never designed a circuit board. So they have to depend on the tools to help them do what us guys used to do, because we're just artistic.
Another good reason for AltiumLive Connect. It's a matter of bringing our emerging engineers. We have the tidal wave of emerging engineers coming out of the schools. We just met one this morning after the keynote, and these are the folks that they're quick studies, right? They can learn software and the layout tools really fast.
Yes.
But like a kid running with scissors,
But
the
if
potential
you-
for injury or injuring somebody upstream
Also,
with a poor
though,
design.
Kelly, you know as well as I do. If you don't know anything about the fabrication process or anything about the assembly process, then what good are you? You have to understand the whole process in order to design a board correctly.
It's no longer can we design in a vacuum, especially now. We've said that the term DFM has been around for years and years and years.
Are here to find your defects.
Yeah. So what do you think about technology and the way it's going? Because I'm sure you're seeing customers that are bringing you challenges. I mean, it's the next level, the next dense package that you've got to put on. Either you're going to figure out if you're going to tool up for it or deal with it some other way. What do you think about what's coming and what the designers will have to do in order to incorporate DFM? In fact, let me make my question crystal clear. Is there coming a point where design for manufacturing has been so almost outdated and we're going to have to start designing with manufacturing?
I think that is a great way to look at it, and yes, because if you're the type of company that just finds the cheapest guy to do the board because you're trying to save a few bucks here, yeah, maybe that's not your best bet. You got to work with your partners and get to where they understand what you're doing and you understand what they're doing, and it's going to help you design, and it's it's going to help them manufacture, right? So it's a collaborative process, and that's the way it should be. Even your fab guys. Don't just throw it to the cheapest guy because that may not be your best guy.
Well, I'm learning a lot. In the last 6 years, I've gone to work. I've gone to work for a bare board supplier, a well-known prototype supplier, and then moved on to an EMS provider in Pacific Northwest. And this is where my eyes were opened, because I started seeing board designs coming in from all parts of the world, and we were having problems with them. Part of the job is to pre-engineer them or digest the design and evaluate it for not only for our assembly line, but for our bare board manufacturers. Where are we going to send this board to be manufactured? And at that point, it's disconnected from the designer. We have to find an assembly vendor who will fabricate it, or a fabrication vendor who will build it. And we get to the point where we send out for quotes, and guess where we go? We go to the cheapest for volume, because if you can save pennies, you can save millions on a design. So
true, but conversely, if you have defects, then you're going to spend millions more.
But it's presumed that we won't have defects. We get the boards quoted from the point of, yeah, without defects, please. We didn't sign anything that said you're going to ship them with defects. So here's the experience. Here's what I learned is we send out to 3 or 4 suppliers, and they send us a quote. The lowest bidder wins it, or whoever we have the best relationship with. And then 4 weeks later, we order zillions of them. And then is when the magic thing called an EQ, an engineering query, comes back from the supplier and says, oh, by the way, we can't do your 2.5 mil wide line in 2-ounce copper. Could you please switch it to, they quoted it already. Right. So this is a big frustration that EMS suppliers have to deal with.
Yeah, and we usually have to take those EQs or TQs, whatever you want to call them, and work with the fabricator. It's not even our design. Yeah. And then sometimes we have to go back to the customer and say, you did this, you answer this. So, there's no such thing as a perfect design, but I think if you work at it, you can get really close.
Right. And then, to circle back to where we started the conversation is that you know, that's where the response comes in. It says, well, our supplier before had no problem with it. And you ask, well, who did it? And it was a prototype supplier onshore who custom built the fabrication atom by atom, you know, so that they could get the clearances done.
You know, sometimes if it's something very trivial, we'll take care of it ourselves. So they'll never know. It'll be transparent to them. But that's not always the case. So, you know, I guess to reiterate, you got to work with your relationship if you want to build good product and build it consistently. So
absolutely. Well, I really appreciate the walk and talk with you. This has been fun. To, you know, it lets our audience see some of the things going on. Look, we got a robot going on here. There's so many robots. They're taking over.
Pretty good crowd here. Not exactly normal, but all things considered, it's pretty decent.
Yeah. Well, I tell you what, we're going to give everybody a rest here. Charlie, elbow bump or whatever we're doing these days. I really appreciate the opportunity to chat with you.
Thanks, Kelly.
Zen Tech, Charlie Capers, you know, you can find him on LinkedIn and ask more questions. Hi, Kelly Dack for AltiumLive 2022 Connect. Hey, we're still down here on the show floor, and we're hoping you're having a good show too right now with all our speakers that are going on the different stages. But for now, we are down here on the show floor, and I'd like to introduce you to George Babka, who works for Yamaha. My goodness, this is an impressive setup you got here. Tell us about it.
Okay, so actually, Yamaha has a couple different booths here at the show. Our distribution partner at Transtech has some of our more common general purpose machines over in their booth, which is kind of the you know, like I said, more common stuff. What we're trying to showcase in the Yamaha booth here is our latest technology and machines that are just coming to the market. Okay, so obviously everyone's kind of cutting back on the show because they didn't know how many people were going to show up. And we still decided to have a full booth, right? So, but the main thing that we wanted to do is show where we're going, right? So, if you know, Yamaha is a manufacturer of pick and place, dispensers, printers, inspection machines, X-ray machines, and storage towers. So we supply those to the industry, and so what I want to show you today maybe is just the three machines here that we're kind of showcasing. One is the YSP10. Okay, so this is a printer that's fully automatic as options. Okay, and some of the unique features of this, other than all of our printers have this a rotating squeegee blade, and if you can look in there while it's printing back and forth, it's just printing on a blank stencil.
So for our audience, when you say printers, we have to assume there's some emerging engineers out here who have never seen the process. So this is valuable being here. We're printing solder paste. Tell us about the whole process and how that works.
Okay, so the deal there is we're printing solder, like solder balls in flux. So it's like a paste material, like a peanut butter kind of consistency, and we print that with a squeegee through a metal stencil. Okay, kind of like they make T-shirts with, although they use a screen for that. Okay, so this technology's been around for a while. So it's kind of mass deposition of solder onto a circuit board. That circuit board, then you place components on it, right? That solder is sticky enough so it'll hold those components until you put it through an oven, which will actually melt all the solder together and use the flux to actually form the solder joint. Okay, so I've been in the printer industry before this, for over 30 years, and over the last, I'd say, 15 years, there's really been nothing new that's come to the market for the printers. It's just like, how cheap can we make this? How many can you have in what time? Okay, so Yamaha is different. I mean, we're still innovating every product line. We're not saying something is a mature technology. So we introduced the YSP10 here a couple years ago, and some of the newer features on this, which that we introduced. Okay, first of all, the standard features for this that make us different in the industry is we have a single squeegee blade. Normally, most printers have two squeegee blades. One will print in one direction, the other will print in the opposite. we have a single squeegee blade that'll actually rotate over the solder roll so that we don't have to worry about solder sticking to the blades because it's always on the same side of the squeegee. But in addition to that, we can actually control the angle. So we can actually control the filling force into the hole, okay? Which is very important in production because as you use up solder, it changes the dynamics of the print, okay? So that's the short answer. I could give you a 3-hour presentation on that alone, but I'm sure that your viewers aren't that interested.
It is a challenge because you know, components on boards sometimes they're mixed technologies and require more solder. Sometimes they're micro technology, and it's hard to squeeze a few balls onto a component land. What's your suggestion? How are some of the stencil? Do you manufacture stencils at all? Or
you know, there's plenty of very good stencil manufacturers out there. One of the things that our machine allows us to do is kind of break over the barrier of limitations between the hole size and the fineness of the powder that's in the solder, okay? Because we can control that fill force, we can actually get more solder through the hole, especially for like through-hole devices. It's not really the small components. It's, well, on that side, it's the fineness of the powder and the size of the hole. But on the bigger stuff, the through-hole components, where you're actually sticking solder, or sticking a component through a hole that's already got solder on top of it, right? It's solder paste. We can get more down because we have a higher degree of force control. Okay, so.
Michael, if you can get just a shot of that line of paste, I'm not sure if I did before, but check this out. You can just
See it? Now watch it.
The solder. You can see the solder roll.
So the squeegee's going to pick up. Now it's going to rotate over the opposite way, and it's going to print in the opposite direction. Okay, so the solder always stays on the same side of the squeegee blade, and since you're not managing two squeegee blades, you're not managing two different solder rolls. Okay, so it gives you a level of process control that's not available on other machines. Okay, so that's a standard feature we've had ever since we made printers starting in 1999. Okay, so but some of the additional features of this machine is that I can automatically change over, so I can pull, first of all, I can scoop all the solder off the stencil automatically. I can pull the stencil out. I can change the pin locations or support locations underneath the board. And then I can move a new stencil in and put the solder down all in less than 5 minutes. Typically when you're changing over a line, the longest thing to do is to change over your solder printer because that takes about 15 minutes. So even for small customers who may be running 5 jobs in one shift, right, having that extra time can allow you to run a whole nother setup in that same time period. So it's kind of like having a sports car and you're hitting every red light along the way, right? Just like, you know, minimizing the time you're stopped, right? So we've always been talking about raw time. How fast is it? Okay, but it's also what's the overall, how many boards did you build a day or a week or whatever is more important than what's the top speed of the machine.
Yeah, that's something I learned going to work as a designer, a PC board designer, going to work for an EMS provider.
Sure.
I learned as a designer that I didn't know before, that time on the assembly lines are measured in seconds. Right. If they, in volume, if they can save seconds, they save lots of money.
Sure, right. And so that's the whole thing. So you have to balance your needs between overall, you know, if you're never going to change over, going to run the same product all the time, that's a different process than one that you change over a lot. So one is focused on shaving 0.2 of a second off the line. You can build an extra 20 boards in a shift versus minimizing the time we change over, right? So when we change over a pick and place machine, we'll just pull all the feeders out on a cart, right? So you can put other ones in and you can go right back to work. So you can set up while the other job is still running. So that's how we do that. Here we're doing something similar. We're already pre-staging the other stencil. We already programmed the solder or the support pins, and so it can automatically change over. So this machine as well is doing a lot of parallel processing. So we can be cleaning the stencil while another board's coming in. We can do inspection, and at the same time that we're dispensing solder. And so really trying to get that overall tack time, measured by a board exiting the machine, not how long it takes any individual board in here, but how often is a board coming out of the machine.
Well, once the process is complete, the board lowers down away from the stencil and creates a geometry of solder paste that it's called release, right?
Yes, right.
Okay, so the release is important. The board goes off. Is it inspected at that point?
It can be inspected in here, and so for lower volume customers, you can actually use an onboard camera to look at all the solder on the stencil, or on the board.
They're checked for a good geometry and good deposition. Right. What's the next step? Where do we go next?
The next step is we go over to the pick and place machine. We have two here. Okay, this is our standard machine. We call the ZLEX or the YSM20. This has been available since like 2015 or so, or 2014. Okay, this is a dual gantry machine. It comes in a single gantry. Here we're showing two separate heads placing on the boards. And the way we actually speed this up is, if you can see this, the tables are split. So the front gantry is placing on one board, and the other gantry is placing on the same design board, because you're building half the board over here on the first stage, and the second half over here. So it almost acts like an internal dual lane system. And so when I split those tables, those heads can actually both place at the same time without crashing, right?
I hope we have enough bandwidth to show the action that's going on there. That machine is screaming. Right. It's amazing.
So, so you'll see this. It'll. Well, I think we have it in dry cycle mode right now, right? So each axis is placing on its own, but with the table splitting, what happens is the tables will come together, boards will transfer, and then the tables will split again, right? So I'm waving my hands a lot, but anyway, so this machine is like, Yamaha every 3 years releases either a revision of an existing platform or a brand new machine. So like every 6 years we'll come out with a new machine. In between we have a speed up version, right? So this is the R series, okay, or the revision series, right? So this gave us an extra 10% output through this. This is about 95,000 components per hour, what they call champion speed with the two heads, okay?
Let me ask you a question regarding component sizing.
Sure.
I was here years ago, and the 0201s came out, and then the 01005s came out. What's the next step, and how are the assembly placement machines handling these newer, micro dust-sized components?
So what we're doing is, 20, 30 years ago, we were talking about going to 06, 03s and how we're going to place these things, and the components keep getting smaller. So, we have this machine is a 35 micron machine. The other machine I'm going to show you is 25 microns, so a higher accuracy for those small components. Okay, so a lot of the problems with smaller components is not actually placing them. It's actually having the vacuum to actually pick them, right? Because you have a little bit of dust in there now. You lose a lot of this vacuum, and then also there's a thing called a component bring back. If I'm placing a component, I've got to drop it so that if I bring it back, then it doesn't end up being placed because there's very little solder on the board. So, we're able to go down sub 0105, imperial down to 0105 metric, right? So I don't even know what that number is, 008, whatever that is, right? but anyway, so we've done that. We demonstrate that all of our machines, actually, before they are sold to the public, they are used to build our own product, okay? So every feeder that we have has a circuit board in it. And so, and some other control boards and stuff that we have inside the machine, we build ourselves. Why do we do that? We do that first to test the longevity of a new platform, and then two, so we can kind of control the production in our own house. But on all of our circuit boards, we have test placements that are not functional components, but we're just using that to do SBC checks on finer, smaller components than what we're currently placing on that individual device. Any circuit board designer can design in these small components, but then the manufacturing engineers are like, if you don't have to use a smaller component, then don't, just because they're more difficult to
Used
operate.
an acronym, and for our audience, we may be introducing some acronyms. SPC is a statistical process control, so it's an inspection point and measurability. Your system adds measurability to, if there's a problem component that keeps happening over and over, you can identify it and fix it.
That's correct. You're right. So. Yeah, so we have a lot of real-time statistical process control tools. We have a closed-loop link with our inspection machines. So if we find a defect in our inspection machine, it'll send that defected image to the screen of the mounter. It'll show a reference image and the defective image, and you can say pass or fail. If it's failed, you have recovery steps right on the screen, so you can say I can look at the tape just to make sure there's components there, it's aligned right. I can actually take the nozzle over the nozzle cleaner to actually blow out any dust, right? And or I can adjust offsets. Okay, so I can do all that inside the machine in real time. Okay, so only the boards in between the placement machine and the inspection machine, we're shortening that whole feedback loop. Okay. So, go ahead.
George, we talk a lot in design in our design classes about manufacturing constraints. And constraints are often dictated by the machinery that's going to be used at the EMS provider that you're doing business with.
Right.
What are some of the latest constraints regarding component placement, angles, proximity to other components? Can you just fly over that concept?
Sure. Right. So our nozzles are getting as components get smaller, placing them next to each other, your nozzles actually have to be smaller. You can't have a big shoulder on the end of them, because then you can actually hit adjacent components, especially if you're putting small components right around an IC or something like that. You don't necessarily have a lot of room. So, we've done tests where you would never do this as a design engineer, but putting in components in between the leads of a leaded device.
I love it.
Look to see if you can, can do that. So we do that. So we have what's called fine pitch nozzles, so we can do that. But beyond that, when we look at other constraints, boards are getting thinner, right? They're getting more highly populated. When they're routed, they're a lot flimsier, so board support becomes more of an issue. So, like we have with a printer, we have the ability to actually put automatic support pin placement underneath the board to support it. Okay. The other thing which is interesting is we're starting to see when people are placing components on top, not on top of other components, but when they place them, they're actually, the tops of them are over the other components. Okay, so when we want to inspect them, which we'll talk about here in a little bit, how do you see a component when you're looking down and there's a connector right on top of these components? And so when we have the ability to look at it from the side and actually do some measurement techniques that way.
Right, so there's often orders of operations that the manufacturing engineers, our stakeholders, based on your design, are going to have to set up way in advance. Order of operation of components. Some chip capacitors and resistors may have a connector, even a surface mount connector placed over,
right?
Which may cause problems with oven reflow and stuff.
Sure, right. It's all tied together, right? So as you get a more denser circuit boards and thinner circuit boards, the entire processing becomes more delicate. Like when you're putting it through an oven, you have to support the board so it doesn't warp in the oven. Then you flip the board over, and so it was bowed like this, and now it's bowed down, right? So ways to actually to support that board. We have several different techniques for that. It's most critical on the printing for support, but even in the pick and place, having reactive force or something underneath it, so when you place, you're not actually flexing that board. Okay.
This is great information for our design viewers and probably our manufacturing audience also. Sure. That's involved. Again, we're trying to bring it all together and introduce our audience to the stakeholders that exist in the rest of the industry.
Sure.
What makes it all work together? How about your finest, your next scale machine?
Okay. So we've taken the technology of the YSM20, and actually, I don't know if you know, but Yamaha purchased Hitachi High-Tech, the intellectual property and the factory people that were building the Sigma. And the Sigma is a machine that Hitachi held the patent. Before that, it was Sanyo for the first rotary head. So you have like a multi-heads, that basically come around in a carousel to pick it up, okay? So over the years, our competitors have found different ways to do that without violating the patent. So when we purchased Hitachi, right, so we are the owner of the carousel head, so we're actually just going around in circles like this. So it's either a carousel, a tilt-a-whirl, or a Ferris wheel, right? So having them all on the same axis allows us we can actually pick two components at the same time and place two components at the same time, okay? So, like if you look at a watch dial, you can be placing it at 3 o'clock and at 9 o'clock, right? But actually, we can place it any orientation, any degree of orientation, so we can get these. You need 33 degrees or 37 and a half or whatever you're placing a component. We're able to do that with this head, okay?
That's required for board real estate or board functionality sometimes, so it's really important.
So what we did was we took the rotary head concept from the Hitachi machine. So this is kind of a fusion between the Sigma and the YSM that we showed you over here to give a single machine. This is also a dual gantry with a split table, okay? But what it'll do is, and maybe you can see it better up here, is, if you look at the video here, right now this is doing a nozzle exchange. All these nozzles are actually QR coded, so I can determine if I have a bad nozzle or I find out I've gotten a poor pick rate with a specific nozzle, it can go and identify that nozzle and exit out so it won't place them anymore, okay? So when you're closing the loop on traceability and things like that, then that certainly helps, okay? So if we look here, this is simultaneous pickup on this video here. I don't know if you can see that. So it's picking up two components, like the 9 and 3 position, right? And placing them on there, okay? So, and this is high speed. They might slow it down here in a second, but in reality, this also not only allows us to pick two components at a time, but I get more, I can do a longer board in a smaller frame because I can actually rotate the head to pick up something all the way on the left. I can pick it up and then rotate it around to the right and place all the way on the other end of the board. Okay.
That's an interesting designer point. Let me pause you just for a sec.
Sure.
What do designers need to know about size of boards? When we're often given the opportunity to shrink boards,
right?
But sometimes we're faced with a challenge of having to expand boards, and fabricators can build a lot of different sizes of boards. The capabilities have come way up, but a designer has to think, right, about the capabilities of the assembly processing, the printing equipment.
Right.
What are some common sizes that the machinery deals with?
Okay. So normally, like in the automotive world, you'll get what's called M-size boards, which are no bigger than like 330 millimeters or by 250. So that's like 10 by 13.7 or something like that in that area, okay? Small cards. That's where these machines, when you split the table, they're completely separated from each other, so I can place on two gantries at the same time. As those boards get bigger, I can still split the table, and I can still access much of the board. In this machine, I have much more access because instead of doing the gantries have to have a physical distance between them. Now I can put both heads, which are now facing each other, placing in the same space, so it's a kind of a dynamic keep out zone, right? I don't want to say crash, you don't want to say firewall anymore, but to keep the heads from operating in exactly the same space, let's just say, we get more efficiency. So even though this machine's only rated for about like 3% faster for the same head design as that, we're actually seeing about a 10 to 15% speed improvement in this machine just because of this dynamic crash zone mapping.
How about with the speeds involved? Old school designers, we used to think of placement and time to place,
Right.
Again, order of operation.
Sure.
Do designers really need to think about this, or do we, as far as machine placement, is there really a time burned up by placing components at an angle? Does the machine have to take time to think and do that anymore?
I think most placement machines now are actually adjusting the angle on the way over to place. So none of that is a concern anymore. However, we used to have what we called chip shooters. So you're only placing small components, and then you have a multi-function machine after, which places your taller connectors and things. Okay. What Yamaha has done is they say, hey, we've got a single head. Our standard head, which we call the HM head, can place a component as small as these sub 105 components, all the way up to 15 millimeters tall and I think it's 55 millimeters square. Okay, all in a single head. Now, if you look at our competitors, you'd have a different head for different sizes, and so that's fine if that's all you're going to build, but you don't know from one day to the next what you're going to build, especially smaller contract manufacturers. You have to have the ability to be flexible without having to say, well, I'm going to pull this whole head out and put another one in to make this run efficient.
Flexibility is key, and if we flip that equation that you just explained, designers don't know where their boards are going to be manufactured. So we're talking about a certain sizes and max component heights that you can assemble. It's very important for the designers to, again, get in touch with who's manufacturing your board, who's purchased this machine from Yamaha, to establish capability and design, be able to design for that. Because if someone doesn't have this machine and may have less capability, you have to design for that also.
Right. So the only thing that still you can't do is you can't place through a shield, right? So if you put an RF shield on, those go on last, right? Because but a lot of times those go on top of other components. So if you're going to inspect that, you want to inspect it, and then you have a small machine afterwards that just place those shields, right? So, and we've been doing that for years. We have a much smaller machine just to do connector placement or shields and things like that after the main SMT and the inspection is done. Okay, so. So anyway, so this machine is we had a revamp of the software. Although a lot of people are used to our software interface from our older machines, we can flip back and forth between that. Right. So this is the old interface. The newer interface will actually show you where the boards are moving inside the machine. Oh, actually, they're doing that right now. So, but as the board gets bigger. Okay, so everyone says, well, I need a machine that'll do 48-inch board because I may be doing overhead LED panel.
Sure, that's real common now.
So how do you do that? In the same machine, when you tell it the length of the board, it'll automatically adjust. So it knows that, hey, once the board gets to a certain length, I can't split the table anymore, right? So it automatically will lock the two tables together, and then it'll operate as a single lane machine where I'm placing with one head, and then that moves out of the way, and then I'm placing with the other, okay? So you lose a little bit of efficiency there, but you don't have to buy a separate machine for that. One of the biggest things that people, they say, is the pick and place big enough to handle this board? Yes, it can handle it. But when you talk about printing, can I handle that long board, right? And then also, when you're talking about these big boards, you need to have conveyors in between them that are enormous. And alignment of machines becomes a lot more critical because now you're talking about a 4-foot panel coming through the machine. So having the capability and not, you say, yes, I can do this in the future if I need to, but I don't need to buy an entire long board line for a product that I don't have, that I'm not building yet. I have the ability to do it on an existing machine.
And that's an interesting point. Accuracy and ability to measure boards. A board is not a bare board that's not manufactured the same as your artwork that's you're viewing on the screen. There are stretch factors and stretch compensations. I know that the stencil manufacturers will make. They'll compensate stretch.
That, right.
So when you're talking about a flexibility of stretch, the placement machines have to compensate for that too. And we use fiducial marks and things. Talk to us about fiducial marks and accuracy and how the machine compensates.
Sure. So you can set this machine up to just look at global fiducials, like just on the corners, or like on a longer boards that stretch or whatever, you can actually set up local fiducials that apply to a certain range of components there, right? So why wouldn't you just do that all the time? It takes time. It's like going over and inspecting an area for a fiducial is just like a placement. So that whole routine, takes time. And when you're talking about, shaving off a half a second or whatever, that becomes critical. One of the things that I would like to note is that our machines have this is a rotary head, but we have scan cameras on all our machines, so we can actually look at a component that's up to 12 millimeters square and up to 6.5 millimeters tall. I can actually look at it without actually having to take it over a stationary camera. So if I'm picking and going directly to the board, that's faster than picking, going over a camera, and then going up to the board. So that's about a 30% time savings if you can do that. So, we did that back in 2008, right? And with these newer machines, we're actually increasing the size of the components that we can actually do that with. For our rotary head, we have fixed side view cameras and a light source in the center of the turret, right? So I'm backlighting the component, I'm looking at the component, and I can see how it sits on the nozzle. If it's not completely centered on the nozzle, I can communicate back to a feeder to adjust the pick position for the next board. And all these feeders are intelligent, so I can save those offsets on the feeders. So if I pick this feeder up and I put it on another machine, it reads all that. So we know how many cycles it's been, how many mispicks it's had, and everything else. And so when we go to calibrate these feeders, we can look at the whole history. After 5 million picks, how many were bad picks? What's the offset and everything else? And so we're getting a level of repeatability that we didn't need 10 years ago. Okay.
How about let me we've taken a lot of your time, and you're a gold mine of information, George. And these machines show really well, and they're just fascinating. Designers have questions about things, constraints, like placement constraints, like how many fiducials are required nowadays. What are the size? The standard 1 millimeter round fiducial, that always works everywhere, but as boards shrink and real estate becomes critical, is there anything we can do fiducial wise or locationally wise? Can you go with smaller fiducials now?
We're talking about higher resolution cameras in the entire machine, so we can actually look at smaller fiducial sizes. And a lot of times we'll just consult with the engineers. If they call and say, hey, what's the smallest we can do? It's like, well, we can test things for you. We can run simulations. We have detailed specs about, like the color of the fiducial and everything else. How it's defined with a solder resist around it, or if it's a zone pad. So there's a lot of things we can do for that. We also have the ability for components that aren't normal components, like battery clips or connectors and things like this that aren't square. We have the option to be able to actually do what they call smart vision, so I can actually create an image for that component on the machine. Okay, so I don't, most of the stuff is actually automatically generated from the CAD data that comes in. Okay, and but for these odd components, we can actually teach those kind of with like a video model teach. Okay, so.
Do you have a minute? Again, I know you need to get back to the show floor, but I see one more machine, and I bet you that's the machine that inspects the work that this machine has done.
Okay.
Let's try it. Follow us. This is wonderful.
Okay. So this is our wire IV. This is our brand new, we call AOI, which is automatic optical inspection. Okay, so we've this is probably the fourth generation of AOI machine that we have. Okay, it's a true 3D AOI, which means that we're actually looking at the board with a top-down camera, right? And then we're also with a moire pattern. We're actually putting structured white light, and we're doing a phase shift on it, where we can actually see the component topography based on the interference pattern we see with these things. Okay, so we have 4 projectors. Okay, why do we have 4? It's like, well, because then if one of the projectors is shadowed by a taller component, we can still see it with the other 3. Okay, But we also have what we call 4D, which means this machine goes back in time. No, it actually, 4D will allow us to do off-axis inspection. So you have a top-down camera that's receiving images for the heights, right? So you do a whole like surface map of heights, right? And then you overlay this video image on it, and then you can actually look at a component after it's placed and rotate it, right, through the 4D cameras, our angular cameras, and we can actually look at the solder joints. Like if you want to look at the heel or toe joints, you can actually see that, right?
Those are beautiful solder joints.
Right. So, you know, is this necessary for everybody? No, but it's nice to do for at a repair station. When you say this is defected, you say, well, is it really a defect, or did I just see a bright spot or a bright pad? Okay. Another thing that this can do is actually, if there's what we call a bonus component or a component that's been placed by somebody else, right? You know, it's fallen on the machine. Since we're scanning the entire board, we can actually identify that board, okay? And
that scan. That's a great 3D scan, and that's using the cameras. That's an actual photographic image in 4D.
The 4D is basically stitching together the four separate camera views and making it a true 3D model, okay? So, you know, a couple other things. You know, you see these characters on here. You know, we have our own optical character recognition that's not just measuring or looking at the matching a video image. You're actually reading this as a 3, okay? So then you can identify the font. If it's not reading it right or whatever, you can set up a criteria, okay? And our machine, and David is our, so he'll hit me if I'm wrong here, but David is our AOI product manager. David Sue, and we can actually set a criteria for each component that if it passes it, go on through. If it doesn't, there's a secondary inspection it can do to verify it's a defect. And you can stack these on top of each other, you know, 7 or whatever. But, you know, we have kind of standard profiles for these things, which makes it easier to program. But if you have a tricky component, there's other things you can do to actually find these things.
What's striking, coming from a design background, we're truly now, and we have been for a while, we're truly to the point of getting an image at the ends of the process, the inspection points of the process, with your 4D capability.
Right.
That image that you were rotating around looks exactly like the front end image that we'll see like on Altium design, CAD drawing. Our 3D capability before the board's ever produced, before the parts are cut. So that's just incredible to me, and I hope it is to our audience.
So here's all the different fonts that it can see. So it's not just saying, well, if the D doesn't look like this, if the D looks like this, on other OCR systems or optical character recognition, it might fail that. Sometimes we call that OCV, or verification only, okay? We're actually detecting this and determining whether it's acceptable, okay? So, and then sometimes it's like, well, here's a date code or whatever. I'm going to ignore or I'm only going to look at the first 5 digits or whatever to say, yes, this is the component, right? But I can also record these other pieces here, these other numbers, for traceability later. Now, all of our machines take pictures of the board throughout the entire process. We can tie all those images together and what we call a, what do they call that?
Threading or something?
Yeah, it's I'm sorry, it's component monitoring. You know, basically if you say, look, if I find a defect here, I can say, what did the part look like when I picked it and when I placed it? You know, and I can tie all those images together, and so what I can do then is determine where the defect occurred. Instead of just saying, I got a defect here, I'm assuming it came from the pick and place machine. Well, maybe it got bumped before it went into the oven, or maybe there's not enough solder that got put on it, or whatever, right? So that gives the operators the ability, or engineers the ability to identify that. Now, what David just mentioned, what we call QA option, is what we talked about before. If I find a defect here, if I'm placing it on a Yamaha machine, I can actually tell what side of the machine it was placed on, what feeder it was placed on, what reel of components, and so I can drill down and get to the root cause in real time, which is significant. I mean, other
traceability of where the problem is. You've got to that thing tells the story, right?
Sure.
And you can walk back through it. Love that.
Yeah. So there's a lot of tools here, and when we've been talking about Factory 4.0, or the fourth industrial revolution. It's like we're trying to get all this information. Yamaha's been doing this since 2012. Okay, we've been collecting all this information and sharing it with our own machines, and now our challenge, which we've met, is to now communicate with other machines that are in our line. If it's not an entire Yamaha line, how do we take information from somebody else's pick and place or somebody else's solder paste inspection machine and input it in? So that's what we're doing. Now we're all speaking the same language. But as far as the data we're sharing, we have over 10 years of experience of actually communicating down the entire line, machine to machine, and then machine to the network. Okay. So there's a lot of things that we can do, and it's not just how many components can you place anymore, right? It's what's my first pass yield here, right? If I get a whole bunch of false defects, another person's got to look at this board later, right? And that takes time, right? And so you build up this reject queue, and then someone has to determine whether they're good or not, right? I can actually, not me, the machine can actually set up an alert to a QA operator somewhere else in the factory on their smartphone. There's a defect here. I'm sorry. And they'll show the reference image and the defective image, and they can decide whether it's pass or fail, independent of the operator. Okay? So a lot of times, if you've ever been an operator on a line, it's like I get graded by how many boards come out, right? So I'm always trying to.
Thank you for that perspective, because that's exactly what we're trying to do, is bring designers to the manufacturing floor, introduce them. I mean, you sell to manufacturers, but you're doing a great job of getting us in touch.
Sure.
And really appreciate that.
That's the whole thing of the feedback loop throughout the company. Hey, this works, this doesn't. This is not solderable. Hey, whatever. And getting the design engineers involved in the manufacturing process, and the manufacturing engineers getting involved in the design process certainly helps. So I know I've taken up a lot of your time here.
No, not at all. You've been a treasure trove of information. We just let the camera run. I hope that's okay with our cameraman Michael and our audience. But we really appreciate this time. I think it was very valuable and educational. Okay. And I'll be back. I want to learn even more. I know you've got a lot of stuff. I've got I've got so many more questions about software and how these things run, how they're set up.
We have a software station down there, which if you have time later, we can show you.
Perfect. What's expected from the designers as far as outputting data? We're a lot more data rich now, so it's a matter of we have buttons to press to output data. Tell us what you like, for instance. Sure. Well, it's been a pleasure. I'll fist bump you, George Babka, and David Sue over in the background. He's been instrumental. Yes. Thank you very much. Let me fist bump you.
Here, so.
Thank you.
My pleasure.
Yeah.
Okay.
Well, for AltiumLive 20, let's keep walking. I'm told we're going to keep walking. Okay. Thank you, gentlemen.
Right,
thanks so much.
All right. You need a business card for me, or no?
I'll take one. Well, I'll come and get it. I'm going to get it. Let us go. Okay. We've got just a few minutes before our next events are coming up, I'm told. So I think I'd like to introduce Coping with Design Challenges with an Intelligent Component Library on one of our event stages. You'll see that on screen. And then there's also Altium Designers Best Practices Part 1, which ought to be awesome. So I hope you can tune into that. And I hope if you've been tuned in for the last half hour or so over here on the show floor with Yamaha, it's been a fun time with these guys, and we learned quite a bit. So I think it's a good time to take a break and let you watch the presentations. I'm Kelly Dack for AltiumLive Connect 2022. Thanks for being us, and we'll see you a little later.
Hi, Kelly Dack here for AltiumLive 2022. You were less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go. Also, don't want to forget that we have a Q&A section here on our website. Make sure if you've got any questions that you'd like me to answer or ask the experts for answers, write them down, send them in. We'll look forward to that. So until then, for our next segment, is Kelly Dack for Altium Live 2022 with Charlie Capers.
All right, thanks, Kelly.
Hi, Kelly Dack here for Altium Live 2022. You were less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go. Hi, Kelly Dack, back to you live from the Apex show floor for Altium Live Connect. Our cameraman Michael and I have been roaming the show floor in between breaks. We kind of set up a few people to talk to so that we can bring to you some interesting technology on the show floor. Let's go around the corner and see what we can do here. With us today is Takamura Hara. From Japan. Are you from Japan?
Yeah, from Japan.
Really?
Yes.
So tell us about your products here.
Okay, yeah. So our main product is a string gauge.
What is your company name, by the way? I'm not seeing it on the...
Yes, my company name is Kyowa.
Kyowa.
Yes, and I'm part of Silicone Machinery's booth.
Okay.
Who they are contractor in the western side of USA.
Okay, very interesting, and you caught our eye because, you know, designers, we need to get in touch with what else is going on in the industry once our boards are designed, and this caught our eye as interesting technology because once a circuit board is laid out, once it goes off to the bare board manufacturer and off to the assembler, there's plenty of stresses that can go on to a circuit board, and one of them is post-assembly handling or installation or automated handling can stress the boards. So tell us about board stress, some of the common stress modes, and how your products handle it, measure it, record it, document it.
Okay, yes. So our main product is a strain gauge. So this is a strain gauge, which is a very small and a compact size sensor. This is very important part for deformation, compressive or expansion stresses happening on a PCB or any kind of material. So strain gauge has been used for fatigue analysis and stress analysis of all industry. Yeah.
So I see some of these strain gauges are already connected, and then they're providing data for your software here to show, explain this.
Yes. So this is a strain gauge. This is actually bonding on a printed circuit board test pieces.
Okay.
So setup is very easy. We can apply the strain gauge onto the target by adhesive glue within a few seconds, 30 seconds. And the strain gauge is connected with a data amplifier, signal amplifier here. This is a PCD400A signal recorder available for 4 analog channel input. And we can stack up multiple units, maximum 4 multiple units. So this is available for 16 measurement channel.
So one per sensor?
Yes.
Okay. Now, these sensors are attached to many boards, or typically one board under test in a run, or for specific circumstances. Say, this board, I see a couple mounting holes on here. A common problem in assembly is the next assembly or post PCB assembly, where the board is going to get installed into an enclosure which may have warped. What happens to the circuit board when the fasteners are tightened down?
Yeah.
It can cause these stresses. So tell us about how this works at this point, and what you see on some of your meters here.
So one of the common failure we have seen is crack happening on the CPU board joint alley. So the common solution is applying the strain gauges onto the multiple corner onto the CPU board. So here you can see a triaxial strain gauge with a 3 axis of the strain gauge. Yes. So by using our software and the data recorder, we can catch up the strain with a real time.
I was dying to do that. I wanted to ask you for your board so I could flex it, and I didn't know if it was the right thing, so I'm glad you did it.
Yeah, so we are seeing the strain value from the 3 axis. And this software is supporting rosette analysis for calculation principal strain in the real time. So this is the most advantage of our software and our strain gauges.
Now, does this data, can we record this data for?
Yeah.
Very useful for analysis and trading analysis, or documenting conditions that aren't intended, but you may have to prove for some reason or other.
Exactly, yes. And right after recording process, this software can generate test reporting document, including every strain data of every seconds. And our software called PCAS 1000A series. This is the parts number for the software and a data recorder complete package set. Yeah.
So this comes as a package, PCAS 1000A, strain gauge recorder, or sensor and recorder.
Yes.
Okay. Well, it's been very interesting. The show has just started, and I see it was hard to get some of your time here because people are definitely interested. So we're happy to bring you to our audience, and we hope our audience appreciates it. I'll give you an elbow bump. Takahiro Hara from Sika Machinery Incorporated. Check these out, and don't stress your boards. Thank you very much.
Thank you very much.
In the meantime, let's stroll on over. We'll walk the show floor here, and we'll check the availability over here at Ko-Young. They have a ton of very interesting assembly equipment. We've been talking about boards and bare boards and what happens to them. So let's see if we can meander in here and make a connection. Ooh, hello. Hi, Kelly Dack. Josh? Joel or Josh? Joel, sorry.
How are you today?
I'm doing very well. With me is Joel Scotchfield.
Look at that,
We
the
haven't
first
met
time.
yet.
Yeah, most people don't get that right the first time. So look at you.
I try hard.
You're
I try
very
really
good at
hard.
phonics, if anybody remembers what that is.
Well, Brent hooked us up. We were strolling the aisles, and we're with AltiumLive Connect 2022.
Okay.
We're live on the stream, and we have viewers here who are, of the printed circuit design audience, and our goal today is to put them in touch with the other stakeholders in the industry, the assembly stakeholders. We just talked about some stress gauging over here. We've talked about solder, how solder is applied to the board. And now we're at in an assembly environment, and you've got a ton of machinery here that puts the boards together. It puts it all together. So we're hoping you can tell us about that. And from a designer standpoint, what can we show designers? Capabilities, and maybe some potential problems or things that our designers could do to improve the process flow as they go through your machines. We can walk.
How about that?
Okay, we can start there.
From an inspection perspective, and that's what we do. We are the leader in this space for inspection technology for PCB applications, and that covers everything from solder paste inspection at the very front of the line to pre-reflow inspection, where we can now verify polarity, part markings, missing, et cetera, pre-reflow, which reduces the cost of repair, and certainly in cases where we have customers that cannot repair, right? It's an edict, right? You scrap that board if there's a defect. That's big, right? It also provides a lot more process feedback into the process itself, right? Maybe I've got an issue that I need to address with my pick and place. Eventually, we'll be able to self-heal with that feeder, spindle, nozzle, right, as well as XY. We then move to post-reflow inspection, where now we're looking at all aspects of the solder joint, in addition to, if you're not doing pre-reflow, polarity, part marking, et cetera, et cetera. So the added element there, of course, is the solder joint itself. And so I was jokingly saying no bottom side terminations, right? That's something that you really, for the most part, need X-ray for, right? We are using structured moire lighting in a 3D context, where we're collecting up to 32 images per field of view to rebuild a 3D rendered image that we can take volumetric and height measurements from. So
I tell you what, as a designer, we like to visualize things, and I have a saying that a picture is worth 1,000 words, but checking out the actual part is worth 1,000 pictures. Would it be possible if we walked down some of your line here and we could get a glimpse of the machinery, and you could tell us what's going on?
Well, I've got a couple things I can do for you. In fact, let me start right here. So we've got a couple of opportunities that we're actually giving away here at the show. We've got something called the Printed Circuit Assembler's Guide to SMT Inspection. Now,
put out by iConnect. I recognize this. They do a wonderful job.
Sure. Yeah, it's not a designer's guide, but it is an assembler's guide, and there's definitely value in that. So we've created this to help our customers understand the entire inspection process, and some of that does cover design for inspection, design for test. Likewise, we have this is our version 9 demo board, and with this, basically simulate all of the various challenges that exist for assembly, right? And again, it's been designed into that board itself, so we can.
The acronym we're familiar with is DFM, Designed for Manufacturability. What's the acronym for designing for maybe failure? DF squared or something.
I think it's really more of a design for test. So what we do in here is we go through and of course inspection is a form of test, right? So we go through various elements of that process, and we talk about actual cases of tests that have been done, let's say, and things that people need to be thinking about, probably more so when they're testing a 3D technology and inspection technology in particular. But yeah, these are very much available.
Both of these publications look really comprehensive. May I thumb through this just for a sec? I'll give you this one just for a sec, but this is the beauty of coming out on the show floor. And you know, for those who can't during this time, can they contact you if this looks interesting? I mean, may I show some of the detail here? The detail of what some common failures, not only a textual description, but look at the detail of photos and diagrams in here. Highly suggest that you contact Co-Young and perhaps get a look and check more out.
CoYoungAmerica.com, all one word.
There's also, I recognize this and I'm familiar with the Connect 007, or the iBooks they call them. Here's yours on SMT inspection, another, it's packed with information.
It is, and we've actually put together a 12-part series of videos that kind of break this down, right? And myself and another one of our engineers who's focused more on the MES Smart Factory side, kind of go through it and talk about the specific elements that are embedded. So yeah, it's very educational, very informative, and you know, as a designer, if you understand the process more completely, you're going to be in a much better position to design effectively for your assemblers. And being someone that started out on the manufacturing side many years ago, and sitting in those design reviews before we had all these fancy tools that automate a lot of it, it's a big deal, right? It really is. I mean, you have to understand what your manufacturers can do, can't do, what are challenges to them, what makes life easier for them. The better you understand all that, the more solid and robust your product's going to be.
Absolutely, not just for now, but for the things to come, because I'm sure you're forward-looking, and you're not only checking out technology now, but what is coming, and how are we going to address it? How are we going to help the industry and the assemblers out there to adjust?
Yeah, the interesting thing about our business is because we are number one in our space, and we do work with the who's who of manufacturers globally, both OEMs and EMS companies. We get brought into those conversations very early for what comes next. You know, you can certainly understand that there are some large, without mentioning names, one particular mobile phone company that doesn't build anything themselves, right? But they want to ensure that the people that are building for them have the capabilities to handle, you know, what comes next from their perspective, right? So we get pulled into those meetings, and the benefit of that is that everybody wins, because we don't do customized applications, right? We build that into our software, and everybody can share in that capability once it's released. So,
well, like I said, I don't want to put you on the spot, but picture's worth 1,000 words, but the actual parts are worth 1,000 pictures. Would you walk us down our line, or could you? I know it's very busy, and there's a lot of sales going on right now.
See if I can find a demo board that we can pull out of the machine and maybe look at a little bit.
You. Sure, we don't want to lose you. Come along. This is what we do on the show floor. Sometimes you got to work to get your information, but you can see that there's plenty of people that are more than willing to help us learn. Here we go. Let's get learning.
We'll take a look. We'll take a look at our demo board here, and that'll give you a little bit more insight, maybe into what we put together here. But yeah.
Fabulous.
Yeah, as you can see, you know, we basically run the gambit, and this is just a comprehensive collection of spacings and geometries for the most part, and we're basically looking at stressing the test environment, right? We want to make sure that our customers understand that when they're evaluating a piece of equipment like this, they absolutely need to push the limits of that piece of equipment and ask the right questions, right? So, you know, we've intentionally designed in a lot of that complexity that we know exists in the
this is interesting because in the pictures in the book, I'm not wearing my glasses, but I presumed that these were failures already on the board that you were going to look for, but it appears as that this board was designed with pushing the limits, weird angled, designed components into weird angles. I get it now. Importance of the physical part.
Correct. No, you're absolutely right. We actually have another sample that is exactly what you just noted, which is it's an identical board. Half has defects built in, and half is known good, right? So that allows us to then, first show the capabilities from the known good, and then verify that, showing how it catches those defects and what they would potentially look like. So again, it's important. It's important for customers to understand, the capabilities of the system, at the far ends, right? Not necessarily in the sweet spot, particularly as we talk about, as you alluded to, future-proofing, right? Yeah, you're buying this piece of equipment. It needs to last 10 years or more, right? It really does, and that's what we're doing.
Okay. Well, I really appreciate your time talking with us and showing us the wares. It's so valuable.
Appreciate the opportunity.
With us has been Joel Scutchfield from Co-Young.
Yes.
This has been so wonderful, a very good interview, and you have so much more to see, but I know you have limited time and you got to get back to your
We
your
run
folks.
the gambit, but you can find it all at coyoungamerica.com.
Okay, very
Easy as
good.
that.
Look them up and get these manuals or these texts. These
We'll be
are
happy
awesome.
to send them your way.
Very good. Thank you very much. Elbow
Very welcome.
bumps.
You got it. Okay, man.
Take it easy. Thank you. Well, this is just another example of some wonderful, wonderful information that you can receive here on the show floor. And for our audience who couldn't make it this year, couldn't make it to Altium, again, our goal here is to bring the show floor of the IPC Apex Expo to you prior to the AltiumLive Connect show, which begins tomorrow, kicks off tomorrow, where we're going to have tons of topics and speakers to explain a lot more of this stuff, explain theories and methodologies and things to consider for board design that are going to help your boards run through the assembly areas, so folks like Co-Young won't have to find any defects. I've been out here on the show floor. I don't know how long we've spent, but it's been a good time. We're going to try and come back to you on the hour or the half hour. So keep an eye for us, peeled for us, and we will sign off for now and see you next segment.
Hi, Kelly Dack here for AltiumLive 2022. We're less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go. Hi, Kelly Dack, back to you on the show floor of the IPC Apex Expo for AltiumLive Connect 2022. Hey, here we are. This the place seems to be buzzing. It's got a little vibe. It's the first day. A lot of people are at classes, but the suppliers. The suppliers are geared up and ready to go. We snuck in here a little bit yesterday, and we were able to see some of the setups, and we tried to get some reaction or some comments, and a lot of them were so busy they just couldn't at the time. So we're hoping to bring you with us to watch and take a look at the show floors and introduce you to some of the suppliers who have worked so hard to set this up and show off their wares. These are the manufacturing process stakeholders. These are the people that our emerging engineers will need to understand how their machinery works and their capabilities. We talked a little bit about that last segment. So follow me. Let's go along here and see if we can talk to some folks at a solder company. Here we have Jeff Giles. I'll give you an elbow bump, Jeff.
How are you?
So glad to
that you. Hold that
no, I'll handle it. But we prearranged a little bit. We wanted to make sure it was okay with Jeff that we talk about his company, Metallic Resources Incorporated, and we've got some questions. We want to talk about solder and what's important. What are the important features of solder, and how will the solder affect the way that our circuit boards, how the attachments are welded.
All right, very good. It's I'm happy to do it, Kelly. I'm happy to be on your podcast or what it might be. Metallic Resources, we are one of the largest solder materials manufacturers in North America. We supply globally just about any electronics manufacturer that you can think of. We supply a lot of different types of products. We supply bar solders, pastes, fluxes, and specifically the circuit boards. We do mostly, we supply HAL products, and what that means is hot air leveling products, so that you can coat your board so that parts can be adhered to the board. And we supply all different types of solder materials, tin silver solder, tin lead solder.
Let me explain for a second or ask questions. You know, we have many finishes for any new designers out there. We have many finishes on the circuit board. This circuit board happens to be what we call electroless nickel immersion gold, but there's immersion tin, and then as Jeff mentions, there's a hotter solder level, and there's all different kinds of coatings which serve to preserve the copper, the bare copper that's etched on the board, in order to keep it fresh so that and unoxidized, so that it can go through the next assembly process.
Correct, and the solder coating will prepare the circuit board for the adhesion of the components that are so important to electronics, right? And our solders are high melting solders, low melting solders. We pride ourselves in developing solders that will create better vias or through holes and better wetting, so that the components will adhere more securely and more fastly, right? So, and we're very proud of that.
So, did we talk about pastes at all, or is this solid solder you're typically providing?
Now, this is solid solder. We do provide pastes. We provide a Type 3 and a Type 4 type paste, and that has to do with the size of the sphere. So we're not into the very, very tiny spheres. We can do BGAs and those sorts of things, and we can make products. We have an in-house staff that we can make products to our customers' specifications.
Wow! So you can make custom mixes of solder paste.
That is exactly right.
This is something new. Very, because I work for a manufacturing company who, you know, sometimes we're getting down to components, you know, that are, 1005s, you know, they're dust. They're basically dust. They're picked in place, but they behave a lot differently depending on the solder composition than other larger parts.
Right. So we work with our customers to make sure that the adherence of the solder component works to their satisfaction, and we might help them with some of their design ideas and manufacturability ideas.
Excellent. What can I ask you about there's so many electronics. Electronics has exploded. We've got some challenges, slowing down the manufacturing process, like availability of components and things. But in general, how much solder is used a year? I don't want to put you on the spot or anything, but I know it's a lot.
It is a lot, and I think one of the concerns with the electronics industry today is the availability of tin. Tin is actually at the highest rate that it's ever been price-wise ever, and there are only so many companies that can produce tin legally and safely. And that's one of the other things that Metallic Resources can offer. All of our products are 100% recycled material, so all of our materials is made from folks like you giving us their used boards, used material. We recycle it and put it back out into the industry.
Fantastic.
And we're very proud of that.
Very good.
If you have supply chain issues, we can help you with that by cutting out that need for raw materials out of the earth, tin and stuff like that. We keep stuff out of the landfills, and we supply our customers with 100% recycled tin.
You're our first interview. The show floor just opened at 10 or so, and we came by and talked to you to ask if we could talk. And you know what? I learned something. This is, boom. First, I learned about solder, and this is why the show is so valuable. Why walking the show floors is valuable to designers, because we need to understand the components, the processes, and the people. And check them out, Metallic Resources Incorporated. We're so happy to talk to you. I'll take my board and give you another fist bump.
All right, thank you
Jeff.
very much, Kelly.
Thank you.
Thank you.
Let's move along. We're walking the aisle here. This is our first aisle at the show floor, and we're going to go down to inspection company. That's another thing. We design our bare boards. But we need to understand, once the solder gets onto the boards, the components. We're going to talk to some assembly people this afternoon, I have a feeling, go down the assembly lines. But once we'll jump ahead, we'll skip ahead. Once the boards are assembled, inspection plays a critical role in how boards, the quality of the boards. Boards can go out in the field. If they're not inspected, we can expect failures, right? So I'm going to be talking to some gentlemen. Let's see if we can sneak in here. Are you gentlemen available to talk to our audience? Great. This is how it's done. You walk the floors, you meet the people, you fist bump them. Boom. Thank you. David White from PDR Rework, PDR X-Ray. Tell us about your company and how you're involved in helping circuit board quality.
Sure. Well, our company was founded, we're celebrating 35 years in business. PDR is the founder of the infrared systems for the rework of printed circuit boards, a number of patents in place. And we also have our X-ray systems. They're 100% built in the USA, exceeding all the safety standards globally. Our X-ray systems have the ability for non-destructive testing. And at this particular show, we are focused on being able to detect failures in the manufacture of printed circuit boards.
Can I pause you for a second? Our audience needs to know what are some of the common failure modes out there that your machinery looks for. It used to be, we had a inspection line and we had people with magnifying glasses, and now technology has changed so that we can't see the solder joints anymore, and that's where X-ray comes in. What are some of the most common failure modes?
Yeah, so there are many, wide and varied, but in particular, what we is the components. And let's say in the example of a bottom terminated component, a BGA. So when the BGA goes through the reflow process, whether it's in a rework system or in a reflow oven, right, there's failures that could occur in that process. One of those failures could be what we call solder sphere voiding. And what that essentially is the chemistry, such as flux, outgasses in the process. Then little bubbles could be formed and then trapped in that molten sphere of solder. Too much voiding in that particular sphere is cause for failure and suspect. And so we have automated systems in our X-ray systems that will scan the component, measure the density of the solder sphere, and determine what the void percentage, either cumulatively or sometimes it's just one big bubble. And that bubble would eventually lead to failures. There'd be mechanical failures and the ability for the electrics to pass through that piece of metal. So that is one common aspect of X-ray failure analysis with our equipment. There are many others, head and pillow. We also take a look at the die bonding of the particular IC to determine if all the wires within a printed circuit board are attached and as they should be. So that's one of probably 100 different but those are common and understood. We also have the ability to be very flexible in our X-ray in the sense that we design and manufacture, and most importantly, we use our secret sauce in the algorithms that we use in the software, which enhances the image clarity that the operator will see, and ultimately the machine vision sees and interpolates and is able to detect the anomaly.
So you mentioned automated optical inspection. So your X-ray machinery is such that it can take a board like this or a very high density board assembly, and it can cruise through and automatically identify these voids or problems that we're talking about. About how long does that take? Does that happen rather quickly?
Well, there's a lot of variables that go into it. It depends on how much the focus needs to be, if it's an extremely tiny object versus a heavy mass object, etc. But typically, once the system is set up, the automated routine can go to pre-programmed teach mode, go to various different components or subjects that you want to take a look at on the printed circuit board, and then shift the X-ray detection, so on and so forth, to all these various points on the printed circuit board. And in that process then is developed the failure analysis mode, where we can detect different failures automatically. So it really depends on that throughput, what the speed is going to be.
Sure. That makes sense. I see a sparkly item here. The sparkly items catch my eyes. Tell us about that.
Sure. So in our rework systems, I think I mentioned, the founders of infrared rework for the entire industry over 35 years ago. Our rework systems use focused IR, which is a visible IR, so we can see where that heating is being generated for that component to reach temperature so that the solder becomes liquidous. All kinds of special algorithms going on to consider it a microwave oven in a crudest sense, but you have the basic controls, and you can set power levels at 70%, 60%, depending upon the mass of the printed circuit board. Well, this has been recognized by the industry, and that's why we're so proud to have this Global Technology Award. This one is for our rework systems, and this is an award that many engineers and peers in the industry review different rework systems. And now PDR is 3 years running as taking the global award for rework systems in the industry. So we're very
right on. Well, congratulations for that. And again, our audience, they're interested in technology, but part of our purpose here is to also guide them to the people that make it happen. So we're glad to hear about that. PDR, what does PDR stand for?
Okay.
I don't want to
So,
put you on the spot.
As many organizations, they have founders, that get things going. So PDR stands for Peter, David, and Roger.
Right on.
You guys way back in the late 70s, early 80s that thought, hey, this is a pretty good idea, and developed it, and rest is history. We operate in over 50 different countries, and I have been with PDR for most of that 35 years.
So for more understanding, you have a lot of shots of your equipment here. We're going to be walking down the aisles later and looking at some more assembly areas. Will we see any of your equipment necessarily on the show floor, or equipment like it?
Well, it's kind of a, you'll see some competitive equipment. The technology is usually based on a hot gas type of delivery heating system. Whereas there are primarily three technologies. One's laser, not so prevalent. One's hot air, forcing a mass amount of hot air onto the printed circuit boards. Then you have IR. There's a lot of principal advantages with the IR method. You can imagine that you're heating up a printed circuit board, and you've got large mass objects such as a super BGA, a connector, etc. Then adjacent to it, small little caps that are barely visible to the eye, some of them in their smaller package sizes. And when you force the hot air onto the system, right, that air's got to go somewhere. You have reflow of these adjacent components, and then that airflow would blow like a lawn vacuum blower, etc., the components off. And so with the IR, it doesn't deal with the hot air. So even though you have a component that's adjacent to a larger mass component that reflows, it will not move off a registry, creating more work and confusion for the operator to get a printed circuit board back online.
So for our heads up, you mentioned the three processes. We've got IR reflow, we've got hot air, and
there's laser systems that are available. They generally tend to be very more expensive, and less flexibility in the range of work that they can tackle. And of course, whenever you have a laser system, there's more safety requirements involved on it.
Okay, Dave, let me elbow bump you or fist bump you. We really appreciate you taking time to talk with our audience, talk with me, and we hope and wish you success at the show here.
Thank you so much.
Okay, we're going to ramble on.
Website,
Hi, Kelly Dack here, live on the IPC Apex show floor. Hey, we've been traveling around. We've got AltiumLive Connect 2022 going on right now, and we are darting in, and hopefully it's a good time to show you what's going on the Apex show floor, to connect you and our audience with manufacturing and all the manufacturing operations here. With me is David Hewitt from CHT. You do a lot of post-assembly work here.
Sure.
Tell us about your products and how that plays into a printed circuit board assembly.
Okay. Well, CHT basically is a global manufacturer of pure silicone chemistry. So we're looking at one component, two component RTVs. And what we're looking at here in the stand, we're demonstrating this new product of ours at the moment, which is our silicone foam. So a two-component silicone foam, it currently expands to about 220%. So if we look at this container here, if we put in a volume around here, we'd witness this growth happening here. And one of the applications that we're targeting is lightweighting, obviously, to get the weight right down in a component. So if you can imagine this component filled with a conventional material, it would be 3-4 times as heavy as this.
Batteries are heavy enough. This is a battery, ganged battery module, right?
And it costs money to transport weight around. Everybody knows that. So with a silicone foam, typical example here is we filled this battery box here, and if we have thermal runaway on any of these units here, the foam will contain it, because we're working to UL94V0. So we're looking at foam containment there. So applications for this would be vibration damping on a PCB, staking. If we look at this PCB here, you'd want to stake some of these larger components. Yeah. stake some of these larger components to cancel out any vibration that's going to damage the unit.
Yeah, these power boards especially contain, we designers, sometimes we refer to them as lumpy components. They're massive components, and in shock and vibration they have to be retrained, or retained.
Will go into a chiller in a fridge or a refrigerator, as you guys call it. So that would just destroy itself if we didn't stake it. So that's what happens there. So that's a little bit about what we're doing with the foam. We also manufacture 1- and 2-part materials. So 1 part heat cure materials, 1 part thermally conductive materials, up to currently working around 4.2 watts per meter Kelvin, which is a good number. So those are the areas.
Some more solid, less foamy potting material. This is also, I think I can feel that it's silicone based.
So this is a 2-part addition cure material, so we're using platinum as the catalyst to cure it. Thermally conductive again, about 0.7 watts per meter on standard materials like this. And we can design these in for you. So if you've got an application that requires more than our standard offering, let us know. Let us know what the volumes are, what you actually require, color, viscosity, rheology. Give us 5 or 6 parameters to work from, and we'll develop your bespoke grade. So that's not an issue for us.
Customization is definitely an option. Tell us how some of these materials are applied, David.
Well, you can do those with 2 ways. Some of them we supply to you in cartridges. Others would be in 200-liter drums. So on the stand here, we're just showing. Yeah. On the stand at the moment is a machine from Versamix that we're partnered with, and we're working with this company. But it doesn't matter who you're with. I mean, we can work out a way of actually dispensing it for you. So you can make these as fancy as you want, but what you're looking at today on the stand is something fairly simple. Foot trigger operation. On the front of here would be a mixer nozzle, combining the 2 products together, 2 materials together, and watch that cure off.
We were speaking a little earlier for suppliers, EMS providers that need automation. This can be automated, yes?
You can do whatever you want. I mean, you could have low-level sensors, high-level, automatically feed into there. Cost goes up with that, but you could make it as fancy as you want. You can have a full automation system where you don't have any operators on site at all. They would all be managed for you. Stir the materials to make sure they're fresh. Vacuum the materials to make sure they're air-free so they dispense correctly every time. Shot dispenser. So we use time, pressure, volume as the 3 main parameters to make sure that is filled.
For our designer audience now, we lay out boards. We concentrate on component placement, laying out the traces, the connectivity. But there comes a point on an assembly drawing where we have the challenge of defining a lot of the requirements, and if we foresee that a certain component must be retained in some way mechanically, like with your products, our job is to add a note that we must apply a certain material, curing a certain amount of time, which goes on to the assembly. As designers, we define that, but it goes on to the assembly manufacturers, and they have to deal with it. So it's important to know what's available, and our designers can contact you. Our audience, our entire audience, can contact you with the constraints, the parameters and the constraints, everything that's plus the information that you can custom mix stuff too.
Absolutely, yeah. I mean, the full temperature range with silicone chemistry, you can go from sort of minus 150 degrees C to plus 300 degrees C. So we're involved with SpaceX and companies like this with the Mars rover and so on. So harsh environments, the mining industry. Automotive obviously is our main area, but it's in every single application across the world. It's a clever chemistry, and we win. Basically, silicones are used purely for for high temperature applications, where a PU or an epoxy would fall down. It's a little bit of an on-cost using silicone chemistry, but the benefits are there. Optically clear materials as well for all these different kind of applications. So yeah, but 1- and 2-part materials from CHT silicones.
Okay, and we always think about reworkability if we ever have to rework, and I can see that I can just guess that some of these foams are a lot more reworkable than some of the solid materials, or especially the epoxies you mentioned.
Yeah, absolutely. Reworkability is no problem for us. So the foam can be removed. The adhesion is there, but you can break the adhesion down, or we can increase the adhesion if you need with a primer. But we also manufacture some gels over here.
Walk?
Yeah, sure. So if we look,
let's go on back
around. if we come around here,
Let me scoot around here.
Yeah.
Sorry.
if you come here, that looks like there's nothing in there at all, but we're looking at an optically clear material. So we would just call that a water clear material. So this one's been touched a little bit, there's some fingerprints on there, but optically clear material for headlight manufacturers, that kind of thing. So when you have a front end impact on your car, usually that lamp is destroyed. Now we're looking at silicone technology to go into the headlamp to protect from impact and also allow the light to transmit through.
Also even for inspectability, you know, a lot of these products, components, after if it's potted, the visibility goes away and the inspectability may go away.
True.
A lot of mechanical stress can happen during the potting stage. I would think that maybe a clear material like this would possibly be more inspectable.
Lighting technology is moving at a rapid pace now, so we're looking at different silicones that will actually, if you look at my hand, send the light in each direction. So the bulb will move, or the LED will move, and run through our silicone into every direction where the lighting needs to go. So as you turn your car, the light will actually follow the road. That's the kind of thing we're working on with our partners. I'm not sure we can see it here, but we've got the thermally conductive grades here as well. So this one's a new one that we've just developed. We've just got some little chiller units on the stand here. So you're not going to get this through camera, but this base plate is obviously extremely cold. We have a silicone on top here, and the transmission of either hot or cold temperatures is pulled through very, very rapidly. So it isn't a sort of a test you can do on a camera, but
thermally conductive?
Yep. So thermally conductive. So if you think of EVs, let's just concentrate on EV. The temperatures now inside those cars are coming up pretty high. Before, when it was a combustion engine, you had about 150 degrees C in the engine block. Now these are crazy temperatures because we're talking about big currents. So what do we do with that heat? We need to dissipate it. And you can do that through an aluminium cooling fin, there's no issue, but you need an intermediary layer between those two components. And we do that with the likes of these thermally conductive materials. So we would bond A and B components together. And the way you do that is use a primer as well. And when you're bonded, you get a fantastic thermal path, rather than just a touch to touch. If we have the adhesion, we can shift that heat away as quick as possible. Longer life components, your car lasts longer is the end game.
Absolutely. I just became an owner of an older model EV, and I'm thinking about this all the time. What's going on with these batteries, and how are they packaged? I haven't really seen them. I drive it and I love it. But you know, this technology is exploding right now, the EV industry. So I'm glad to see you're supporting it.
There's something around 2 to 3 kilos of silicone on every car on the planet at the moment. Yep. So we won't go through all the applications, but you can imagine it's all the way through the car. And we're involved in every application on those. So literature behind me will tell you exactly where we're used.
How about your molding? Do you create the molds, or do customers typically create
Customers would create the molds. So we would make a customer-specific material that they want, either 1-to-1 ratio, 10-to-1, whichever they need. And again, going back to the color, the viscosity, whichever parameters they want to fix in place, we'll make that for them. But so we would supply in the A and B component molding rubbers. They would then take that and make whatever they want, pour it into a mold, do whatever's required.
Well, is there anything else you'd like to show off to our audience here? That's good.
We've looked at all the thermal materials, optically clear. So if you just think of high temperature, low temperature silicone materials from CHT. And as I say, we're a global player, so we manufacture in about 7 or 8 manufacturing plants around the world. So what we're trying to achieve is get the same product in any manufacturing location around the world.
So how our designer audience can call you or email you or look you up on the web with questions. Again, we're all about constraints. We need to know the performance and the specifications of your materials so that we can call them out.
So we're a global player, so as you can probably tell from my voice, I'm from the UK. So I'm over here to support these guys with, thank you, I'm enjoying my time here. San Diego is amazing. So I'm over here to support these guys as much as I can with the information we already do in Europe. How can we transpose that over into the US market and likewise in return? So that's how we work, and what we as a company transfer information benefits you guys as well as users.
Well, very much appreciate your time, David. With me has been David Hewitt for CHT, and we're walking the show floor here, and we're hoping you're following along. So thank you very much.
You're welcome.
Yeah, look them up. Yeah. Yeah. Thank you very much for your time. Wonderful. Right now, we're going to be what's coming up at 1 p.m. We want to tag the Altium Designer Best Practices Part 2, which is coming up from David Haboud. It's in our Power User series. Also, Vincent Mazur is going to be presenting Avoiding Supply Issues, and that's over in our Design Challenge stage. So make sure and tune in at 1 o'clock. We may look right and left and go get a bite to eat until then. So we'll end this set and hope you're enjoying it. Hope you're enjoying Altium Live Connect 2022. Connect with us. We'll see you back.
Hi, Kelly Dack here for Altium Live 2022. You were less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go.
www.pdr-rework.com. Lots of great videos, useful aids for industry partners, and appreciate you stopping by today.
Very good.
Thank you so much.
All the best. Okay, let's move on. Thank you, gentlemen. We can walk the aisles here. At this point, we're going to probably, it'd be a good idea to give us a rest, and we'll give you a rest. That was a lot of information to digest. So we'll plan on coming back to you at least on the half hour. We have our full screen up when we sign off, so hopefully we tend to aim toward the half hour or even the quarter, so watch for us. And in the meantime, watch out, look the people we've contacted up, give them a look and see what else you can ask them. The key is get in touch and connect. So I'll sign off for this segment. Kelly Dack for Altium Live 2022.
Hi, Kelly Dack here for Altium Live 2022. You were less than 24 hours out from the show. Won't you log on and join us and connect?
All right, we're on the show floor, masked up and ready to go. Hi, Kelly Dack here, back for our next segment. Altium Live 2022, we're on the show floor with Patrick Crawford. Hey, Patrick, this has been wonderful. We just watched the introduction to this long-anticipated design competition where we have 3 finalists. Tell us, for those that may not have seen what we were able to kind of sneak in and do.
Yeah.
We didn't even ask. We should have.
It's okay. Invited anytime. Yeah.
Tell us about it. Tell us, how it's working and what has led up to this portion of the event.
Sure. So we have the finals heat of our PCB design competition. Earlier in the year, later last year in 2021, we had 14 individuals from around the world submit complete board designs. They were judged, and we whittled it down to 3 finalists. Those finalists are joining us here today, at least virtually, and they are going to be completing a routing competition. So it's only going to be routing and some component placement, and they have 4 hours. So it's pretty tight, but we're excited to see what they can do. We have their design tools, Altium Designer. They're all using Altium piped through the house here. So it's exciting. I'm looking forward to see what they can do in only 4 hours.
It has been so long since I've seen a design competition in the industry at all, and so glad that you've resurrected this. And do you mind if we kind of let's walk and talk and tell us about what's going on? I mean, we're actually seeing the software, and we're seeing the designer working on it. This is unique.
Yeah. So we thought it would be really we thought it would be really fun to. Of course, thank you. We thought it'd be really fun to not only watch what they're doing, but also, of course, to make sure we can see them as well. So Zoom worked. I think Zoom works for everyone these days. That's kind of the de facto space. So it's pretty simple. We just are watching them design, making sure we can see their bright and shining faces. And I don't know. There's not much more to it. It's just a simple way to get everybody involved, I guess. It's fun.
You think it's simple, but this is a very complex arrangement here to make all the connectivity work. To be able to display what people are working on to an audience, the pressure's got to be incredible for these designers. What do you think? Have you sensed any anxiety, or are they, at this point, they're all pretty well